Hi y'all. In 5.4 we'll be dealing with rational equations. This is going to extend the ideas of 5.1 through 5.3, and rather than just simplifying, we're going to work on solving equations. There's a very basic idea involved in 5.4 that we're going to use to help us solve these things, and that is that if a fraction that looks like a plus b, rather a divided by b, equals 0, that tells us that a has to be 0. That is, in a rational expression like this, the numerator is 0. When the numerator is 0, the overall expression is 0. That's because if I take something like 0 and I divide it by 5, that's 0. Alright, and there's no other way to make this 0. The only time that a divided by b is 0 is when the numerator, the top part, is 0. Okay. Another thing that we know about a rational expression like that is that b can't be 0. If b is 0, the overall expression is undefined. So again, something like 7 divided by 0 is undefined. So we need to find out places where the numerator, where the thing like a, is 0, and where b is not 0. So that's the idea behind everything we're going to do in 5.4 about solving rational equations. To take this a step further, we're going to use our ideas from simplification first to write things like this, to make one fraction on typically the left-hand side, and have that be equal to 0. Then we're going to be concerned with where a is 0 so long as b is not 0. That's the idea. Now let's look at some examples. Looking at example 1, one of the first things I want to notice about this is there's not an equal 0 part to it. So the first thing we need to do is set this entire thing equal to 0. To accomplish that, I'm going to subtract the right-hand side, the 6 divided by 2x minus 3, from both sides. Doing that, I'll get that the original expression is equal to 2 over 2x minus 5 minus 6 over 2x minus 3. And that's all equal to 0. Again, my goal is to make this kind of look like we had in the last thing. I'm going to put this over in blue up here. I want something of the form a over b equals 0. That is, I want one rational expression. I don't want to subtract two things like I have here. These are subtracted from each other. I don't want that. I want one overall expression. Alright, so I need to make that happen. I also want to pay attention to where the denominator is equal to 0, and we'll take care of that in just a second. But to make one expression here, I need to find the least common denominator between these two expressions, and that's going to be 2x minus 5 times 2x minus 3. And I'm going to multiply the first expression by 2x minus 3, 2x minus 3, divided by 2x minus 3 to make that happen. I'm going to divide the second expression, or rather multiply the second expression by 2x plus 5 over 2x plus 5 to make that happen. Would have been nice if I had a little more room to do that, but we'll go with this. So that first expression, I'm going to multiply the 2 times the 2x minus 3. That'll be 4x minus 6 minus 6 times 2x plus 5. All over that quantity 2x minus 5 times 2x minus 3. Once I have this all together, and before I simplify anything else, I'm going to look at the domain. So let's pay attention to the fact that I need to look at the domain here. So let me put the domain over here. For this domain, I'm concerned with making sure the denominator does not equal 0, so I'm going to make sure that 2x minus 5 doesn't equal 0, and the 2x minus 3 doesn't equal 0. So adding a 5 to both sides in the first instance, we'll get 2x should not equal 5. Dividing both sides by 2, we'll get x should not equal 5 halves. From the second part, we'll add 3 to both sides. We'll get 2x should not equal 3. Dividing both sides by 2, we'll get x should not equal 3 halves. What this is going to tell us here is that as I solve this, I know x can never be 5 halves or 3 halves on this problem. So if when I come through and I do everything else in the solving and I get a final answer and it's 5 halves or 3 halves, that has to be excluded. That's the purpose of paying attention to this domain. So let's go through the problem and let's look again back at that when we get to that point. So our goal here is again to get it into this form, a over b equals 0. Well, we actually have that now. Let's simplify that numerator a little more, but we will already have that in the form we want. So we're a lot of the way toward where we want to go with this. Alright, in the numerator, that should be 4x minus 6 minus 12x minus 30 all over 2x minus 5 times 2x minus 3. That should all equal 0. In the numerator, again, a little bit more here. Get a negative 8x minus 36 when I combine like terms, all over 2x minus 5 times 2x minus 3. That should all equal 0. Okay. From our previous discussion, we know this. This is going to equal, this expression on the left is going to equal 0. This part right here is going to equal 0 only when the numerator is equal to 0 and the denominator is not. So let's set that numerator equal to 0. That 8x minus 36 should equal 0. And sometimes it's helpful for me to think about it like this. You can think about doing this by multiplying both sides by that denominator, by the 2x minus 5 times the 2x minus 3. And that's what's canceling out here. That's one way to think about it. Alright, going from here, I can add the 36 to both sides. I'll get a negative 8x equals 36. Let me write out the plus 36 here. And then divide both sides by a negative 8. So I'll get x equals a negative, well, those have a 4 in common, 9 halves. Alright, now, one again thing I need to be careful to do is to pay attention to that domain. So I see here x should be a negative 9 halves to make that numerator equal 0. That's in the domain because it's not 5 halves or 3 halves. So that's my solution here. So that's the solution of this equation, and that's what I was looking for. Alright, on B, let's do this one slightly differently. Here, I'm going to start by paying attention to the domain. The domain is going to come from where everything in the problem is set equal to, every denominator is set equal to 0. So I could have to worry about 3t, 6t, 2t, or 3t. Well, if I look at that, that's really equivalent to looking at the least common denominator of the overall expression. So let's find the overall denominator's LCD, that is. So looking at 3t, 6t, 2t, and 3. Take a second and try to figure this out yourself. But the least common multiple of these four terms, which is the least common denominator overall, should be 6t. So when I'm combining this together, that's going to be the denominator I would have. 6t is what it would be, so 6t is really what can't equal 0. Well, dividing both sides by 6 here, this is going to tell us that t shouldn't be 0 as our final result. Once we've taken care of that, that really gets us to back to this point up here. If I look at that blue expression, well, I'm going to move it down to the bottom here. Let's examine that a little further. A over b equals 0. Well, a normal sort of thing to do here would be to multiply both sides by b. And that would just say that a is got to be 0. And that's kind of what we're saying, is the numerator has to be equal to 0. Except we have to pay attention to this domain. So when I started with that a over b equals 0, I have this added responsibility of making sure that b cannot be 0. So that's very important. We need to focus on doing that first. But once we've done that, we're only concerned with the a. Now, we still need to make sure it's all together in one expression, but that's not as bad as the overall result. To make my life simpler here, and this is a process you will frequently want to do, let's actually multiply everything in the entire, on both sides, by that 6t. So I'm going to multiply this first expression by 6t, the second expression by 6t, the third expression by 6t, and the fourth expression by 6t. That's always okay, so long as t is not 0. We can do this. So that first expression, 6t times 4 over 3t, well, the 3t's cancel, I'm left with 2. That becomes 2 times 4, plus the second expression, the 6t's cancel entirely, plus 1, equals 6t times 7 over 2t. Well, the 2t's cancel, I'm left with 3 times 7, plus 6t times 1/3. The 3 cancels with the 6t, and I'm left with 2t. And the numerator, 1 times 2t. Alright, on the left-hand side, that's 8 plus 1 equals, on the right-hand side, 21 plus 2t. Alright, so 9 equals 21 plus 2t, subtracting 21 from both sides. I'll come over here. I've got a negative 12 equals 2t. Dividing both sides by 2, I should see that t is a negative 6. Negative 6, last I checked, is not 0, so that should work. So my solution to B is negative 6. Now let's go on to C. In C, we're going to continue on with the idea we started with last time by first trying to find the least common denominator of the overall expression, and then using that to help us find the domain, and then using that to simplify the overall problem before we work on solving it. Okay. To help us do this, let's first factor this x squared plus 3x minus 4. That will factor to, let's see, that should be x plus 4 times x minus 1. Again, hopefully you're working these through before you look at this. So the overall LCD for the entire three expressions should be x plus 4 times x minus 1. This is going to tell us that the domain of the overall is where x does not x plus 4 does not equal 0, along with where x minus 1 does not equal 0, which is where x is not negative 4 or 1. Alright, now what we need to do in this problem then to get rid of that those denominators is to multiply each expression by x plus 4 times x minus 1. So let's kind of rewrite this. So I'm going to take this x plus 4 times x minus 1 times x squared plus 8x plus 6 over x squared plus 3x minus 4. Let's rewrite that denominator. Since it's equal to that, maybe it's more useful to have it as x plus 4 times x minus 1 is equal to x plus 4 times x minus 1 times 3 over x minus 1 minus x plus 4 times x minus 1 times 2 over x plus 4. Alright, now a point in doing this is that we're going to see a lot of things cancel. So here the x plus 4 and x minus 1s cancel. We're left with, on the left hand side, x squared plus 8x plus 6 equals, in the first expression on the right, those x minus 1s cancel. We're left with 3 times x plus 4. 3 times the quantity x plus 4. Distributing that 3, we'll get 3x plus 12. And that last expression, the x plus 4s cancel. We're going to get, well, we got this negative here, so it's really a negative 2 times the quantity x minus 1. Negative 2 times the quantity x minus 1. So negative 2x, and this is the important part, negative 2 times negative 1 is a positive 2. Be real careful with that sign. Alright, let's combine the like terms on the right hand side of this expression. So just bring down the left. We're going to have 3x minus 2x, that's a single x. 12 plus 2 is 14. Subtracting the x and subtracting the 14 from both sides, minus x minus 14. We should get on the left hand side that our expression is equal to x squared plus 7x minus 8 equals 0. Now let me kind of stop here at this point to say we have an x squared term. Typically with x squared terms, when we have expressions of this form and we're solving this sort of polynomial, we want to get all the expressions on one side. This is somewhat different than what we would do with linear equations, and I want to make sure that we're focusing in on that like we did in chapter 4. But we need to make sure that we have all of those terms on the left hand side so that we can then factor and use our appropriate rules from there. Alright, x squared plus 7x minus 8. So this should be x plus 8 times x minus 1 equals 0. So setting the x plus 8 equal to 0, and along with setting the x minus 1 equal to 0, we'll see that we'll get x equals negative 8 from this part of the problem. Adding a 1 to both sides over here, we'll get an x equals 1. And now we have to be completely careful, or all of that work will have been for naught, because we have to check this domain. So our domain's over here in purple, circling it with red. And it says x can't possibly be a -4 or a 1 in this problem. Those would make the original expression undefined. That's a problem. -8, that's good. We're okay with that. That's part of our final answers. But in the domain, we said that x can't be 1. We have to exclude that from the answer. All this work will cause us to see the answer wrongly if we're not paying attention to the domain here. So again, we did that on A and B. Didn't matter. That wasn't a problem in the solutions, but we have to make sure to exclude the 1 here on C. And that's what that's going to look like when we have those run into those problems. All right, let's go through D. On D, we're going to start the same way. We're going to look for the overall LCD and use that to help us find the domain, and then use that to simplify the overall expression. Okay, so the overall LCD, let's first factor the z squared plus z minus 12. That factors to be z plus 4 times z minus 3. Well, that looks like our overall LCD works out pretty nicely here. It's going to be z plus 4 times z minus 3. So our domain, we'll write it in blue this time. Our domain here should be where z is not a -4 or a +3. And again, I got that by setting each of those terms above equal to 0. Alright, so going through on this, I'm going to go through and I'm going to take that z plus 3 times z minus 3 and multiply everything on each side by that. And I want you to work this out yourself and see that you get what I'm going to get here. And I want you to do that carefully first. Alright, welcome back. So when you do that, you should see that the z plus 4's terms cancel with the first expression, and we're left with z plus 1 times z minus 3. For the second one, we're going to have z plus 1 times z plus 4 because the z minus 3 canceled out. On the right hand side, z plus 4 times z minus 3 was equivalent to the entire denominator, so it's all going to cancel out. We'll be left with z squared plus z plus 16. Alright, a few different ways to go with this, but let's just kind of go through in a relatively straightforward manner and FOIL each of the two terms on the left hand side. Then we're going to combine like terms on the left hand side and then combine like terms overall. So going through with the FOILing on the left hand side with the first expression, two terms, we'll get z squared minus 3z plus 1z minus 3. Now FOILing the second expression, so just to be pretty clear about this, this all came from FOILing that z times z plus a -3z plus 1z minus 3. Alright, doing the same thing over here. Z squared plus 4z plus 1z plus 4 is how that will work out. Again, z squared was the first term, then plus 4z plus 1z plus 4. Alright, and that's all going to be equal to z squared plus z plus 16. On the left hand side, if I'm combining like terms, let's cancel them out as we go. Got 2z squareds, so that'll be 2z squared. For the z terms, I have a minus 3z plus 1z, that's a -2z, plus 4z, that's a positive 2z, plus 1z, should be a positive 3z. And you got a minus 4, and rather a minus 3 and a plus 4, that's going to be a positive 1 overall. So on the left hand side, that simplifies down to be 2z squared plus 3z plus 1 equals z squared plus z plus 16. Now again, this is a quadratic expression, or it will be when I get everything on one side, so I want to make sure I have everything on one side together first. So I'm going to subtract that z squared from both sides, the z from both sides, the 16 from both sides, because that's going to leave me with a 0 on the right hand side, so that I can factor and then cancel out things as I go. Alright, on the left hand side I should have z squared plus 2z minus 15, and that all equals 0. So continuing with this, z squared plus 2z minus 15 will factor to be z plus 5 times z minus 3 equals 0. Setting each of those expressions equal to 0, I should get that z equals negative 5 along with c equaling 3. Again, you must go back and look over here at the domain. In the domain, I saw that z cannot equal negative 4 or 3. So z can be anything other than negative 4 or 3. Since 3 was part of the solution I came up with, I must exclude that and make sure that my final answer only includes the value z equals negative 5. In example 2, the question reads, for the function f of x equals x plus 3 divided by x, solve f of x equals 4 and determine what points this solution represents on the graph of y equals f of x. Okay, the first thing I want to point out on this problem is to look at the domain of f of x. Alright, we'll do this off to the side here. So we want to look at where f of x would be undefined. What would cause us problems in the expression, in the function x plus 3 over x? And again, the kinds of problems for the domain we can run into in rational expressions is where the denominators could equal 0. So we have to make sure that x from this part right here does not equal 0. That's the denominator we have there, and that's it. So the domain is the set of all x so that x does not equal 0. Okay, well, here we're told to solve f of x equals 4. We know the function overall, f of x equals x plus 3 over x. So f of x should equal 4, and it should equal x plus 3 over x. I'm pretty sure that's the same as saying 4 better equal x plus 3 over x. So we want to solve that. Alright, the idea again here is that we need a 0 on one side of the equation. And we can do things like we were doing in the last couple of problems. We can get rid of the fraction. That was really what the process we were doing before was about. If I look at this problem, the overall LCD of things that are in the denominator, the overall least common denominator, well, there's only one thing anywhere in the problem in the denominator, and it's x. So I'm going to multiply everything on both sides of the equation by x. On the left-hand side, that will simplify to be 4x. On the right-hand side, distributing the x times x is x squared. X times 3 over x should be 3, so it should be x squared plus 3 on the left. Looking at this, hopefully you recognize this as a quadratic sort of problem. So we want to get everything on one side. So I'm going to subtract the 4x from both sides. We'll have 0 equals x squared minus 4x plus 3. And we want to try to factor what we have on the right-hand side there. Hopefully when you work this out yourself, you're going to get that x, this factor is to be x minus 3 times x minus 1. And we have that whole right-hand side equals 0. So I can break that up into a couple of parts like we've been doing. So x minus 3 can equal 0, or x minus 1 can equal 0. Adding 3 to both sides, we'll see that x should equal 3, or adding 1 to both sides, x should equal 1. Alright. Oh, well, before I circle out, let me actually read the question. For the function f of x, solve f of x equals 4. We did that. And determine what points on the solution this represents on the graph of the function. So this was our solution. That's that part. Now I need some points. Points. Let me give myself a little more room here. Just a little bit. Okay, when x equals 3 in this function, well, I could find f of 3. F of 3 would be, well, plugging it in for x everywhere there's an x. 3 plus 3 over x is 3. 3. That should be 3 plus 1. That should be 4. Okay. Well, let me think about that. So what we did in this problem was we determined the x values that would make the overall function 4. Well, when I plugged 3 in, I saw that the overall function was 4. That's exactly what I expected. So this is going to represent a point at 3, 4. When x is 3, y is 4. This other x value over here, x equals 1, corresponds to the point when x is 1, and you can replug 1 back into the function, but you'll see that the y value here is 4. The y value is 4. That was the point of this x equals 1 it was the value of x that we get when y is 4. So that should be equivalent to the point we have at 1, 4. And that's what this problem asks us for, and that's our solution. So we have the solution, the x values are x equals 3 and x equals 1. The corresponding points are at 3, 4, 3, 4, and at 1, 4.